Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 5E Part 3 assignment. Okay, first one we're going to start with here is number 5. Drew invested 5,000 euros in an account paying 4.2% interest compounded monthly. All right, find the amount in the account after 7 years, and then Part B, calculate the interest earned. So, invested 5,000 in an account. So let's use our formula. Okay, so here's our formula. All right, so the investment is going to be the PV because we're trying to figure out the account, how much is in the account 7 years later. That makes it the future value. So for part A, we got future value equals 5,000 times 1 plus our rate is 4.2. Divide by 100 times our K. Compounded monthly means that our K is going to equal 12. So 100 times 12, all to the 12 times, and find the amount in the account after 7 years, 12 times 7. Okay, so simplify these first here before putting them into your calculator, and we get 1,200. And then 12 times 7 is going to give us, what, 84? Okay, and then we can put that all into our calculator, and away we go. So 5,000 times 1 plus 4.2 divided by 1,200, all to the 84th power. And we get 6705.48 is what the future value will be. So that's how much they've got in the account after 7 years. Now, part B says calculate the interest earned. So to figure out how much interest you got, it's basically you take your future value minus your present value, right? It's basically how much we started with 5,000, we ended up with 6705, so we take 6705.48 and subtract our original $5,000 from that. And we get 1705.48 is how much interest was earned. All right. Next one, number 9. Donald bought a new stereo for $458. If it depreciated in value by 25% per annum per year, find its value after 5 years. Okay, so we can still use this formula. I think it can make life a little bit easier this way. So bought it for $548. That's the present value. He's trying to figure out how much it's worth in 5 years. So future value is going to equal 458. That's 5 times 1 plus, and now it's depreciating by 25. Depreciated is key in here, so that's minus 25 over 100. Doesn't say anything about compounding periods, so that means K is 1. And then this is for 5 years. Right, so we just get rid of those ones, and this is what we're going to put in there. So we get our calculator, 458 times 1 minus, minus 25 divided by 100, all to the 5th power. And that tells us that it's only going to be worth $108.69. In 5 years later. Okay. Okie dokie. So, next problem then. Let's look at number 11. Business deposits 80,000 euros in an account that pays 5.25% per annum compounded monthly. How long will it take before they double their money? Okay, so now this one's a little trickier. We're investing 80,000 euros. So we know that that's our PV, 80,000 euros. Okay. Now it says, how long will it take before they double their money? Well, guess what? That's just going to be twice 80,000, right? So this over here is going to be 80,000 times 2, which is going to give us 660,000 equals 80,000 times 1 plus our rate of 5.25 over 100, compounded monthly, so our K's are going to both be 12s. And then And it says, how long will it take before they double their money? So we're trying to figure out what the N is. Okay? So here's what we want to do. Super important on this one here. Now, our variable is in the exponent. This means we want to do logarithms. Okay? You can also solve this by graphing, but I think, man, you get used to doing this stuff with logarithms, and it's going to make your life so much easier instead of having to rely on graphs, because I don't think graphs is going to really help you out, help you understand this nearly as much as logarithms are. Okay? So what we want to do is we want to get this all by itself. So this is attached to this big piece here, which is loosely attached by this 80,000. The first thing we got to do is get rid of this 80,000. This is 80,000 times this, so we got to divide by 80,000. Okay? Divide. I cannot tell you how many times I see on this very common error is people try to subtract 80,000. If it was 80,000 plus this, then that would work, but it's 80,000 times that. So to undo multiplication, you have to divide. And guess what we get over here? 2. Okay, that's significant. I'm going to show you why here in a second. Once we figure out what this is, let's plug that into the calculator. That's going to be a 1200, right? So we're going to do 1 plus 5.25. Right? Oh, sorry. Divided by 1200. One more. Oop, too many zeros. And we got 1.004375. All to the 12n. Okay, now, excuse me, this 2 is significant because guess what? That is the double piece. If it was how long before they tripled their money, you'd do 80,000 times 3, and that would give us 240,000. 240 divided by 80, guess what would give you 3? So this double your money, that's that. Whatever you're doing to your money, that's what's going to end up here. Okay? Anyway, now that we have this, logarithms is going to make this so much easier. So take log of both sides. Log 2 equals log 1.004375 to this 12n. And remember, this 12n now comes out front here. So it's really 12n times log 1.004375, and that equals log 2. So then we divide both sides by log 1.004375, log 1.004375, and that's going to tell us what 12n equals. Not what n equals, but what 12n equals. So anyway, let's do this. I'm not going to clear that out because I want to do this. I'm going to do log 2 equals, oh, I can't quite do it the way I'm doing it here. Anyway, divide by, and now we're going to do log of this 1.004375. And that gives us 158.78. 158.78 equals 12n. Divide both sides by 12, and that will tell us how long it's going to take. So divide that by 12, and we get 13.23. So about 13 and a quarter years is about how long it's going to take. Okay? Okay. Let's move on to the next one we're going to look at is 13 here. Investor has purchased rare metals for $10,000 and hopes to sell them 3 years later for $15,000. What must be the annual percentage increase in value of the metals be in order for the investor's target to be reached? Okay, so purchased for 10, wants to sell them 3 years later for 15. What's the annual percentage increase in value? So starts with 10,000, wants it to be 15. So we got 15,000 equals 10,000 times 1 plus, we don't know what the R is, so we have to leave R there, divided by 100. And then doesn't say anything about compounding periods, so those k's are both 1. And then this is 3 years later, 1 to the third power. Oops, sorry, to the third power. So get rid of those 1s. And we want to just solve this thing for r. So first thing we want to do, get rid of that 10,000. So divide both sides by 10,000. Right? And that gives us 1.5 equals 1 plus r over 100 all to the third power. Okay, so he's bought them for 10,000, wants them to sell them for 15,000. The 1.5 means it's worth 150% of the original amount, which is 150% of 10,000 is 15,000. Okay, so here's what we want to do. We want to get rid of that cube, so we're going to actually cube root both sides here. Right? And we get 1 plus r over 100 is going to equal whatever the cube root of 1.5 is. So on mine, I think I actually have a cube root button. Yep. Cube root 1.5 gives us 1.1447 equals 1 plus r over 100. So subtract 1 from both sides, and we get 0.1447 equals r over 100. So to get rid of the 100, we just simply multiply both sides by 100, and we get that the rate is 14.47%. So it's going to have to increase by about 14.5% per year over 3 years in order for it to be worth $15,000 3 years later. Okay? All right, one last one to look at, number 16, a new sports car devalues from $68,500 to $26,380, and I think that's pounds, over 4 years. Find the annual rate of depreciation. So we're looking for this, we're looking for the R again. So starts it with this, ends with that. So the ending amount is $26,380 because it's depreciating. The value of the car is going down. I started at $68,500. And then we got 1 plus our R, that's what we're looking for, over 100. And then since it's talking about the annual rate of depreciation, that K has to be a 1. And then this is over 4 years. So we get rid of those 1s. And this is our formula here. So divide both sides by 68,500. Right? And we get 26,380 divide by 68,500, and it's 0.385. 0.385 equals 1 plus r over 100 to the fourth power. Now what this means is in 4 years' time, the car is worth 38.5% of what it was originally, which is pretty sad, but oh well. We want to get rid of this fourth power, so we take the fourth root of both sides. Okay, so that cancels that out. We get 1 plus r over 100 equals whatever our fourth root of 0.385 is. So on mine, I'm going to have to do 4 and then math, and then I got to do this little x root. That's number 5. So it's going to tell me fourth root of, and then I'm going to do second answer, so I don't have to put my rounded answer. I'm going to put my unrounded answer in there. Okay, well, unrounded at least to 10 decimal places. So fourth root of that gives us 0.7878. 0.7878. Okay? Equals 1 plus r over 100. Subtract 1 from both sides. So we take that and subtract 1, and we get negative 0.2122. Negative 0.2122 equals r over 100. Last step is to multiply both sides by 100, and we get that our rate is negative 21.22%. So annual rate of depreciation is 21.22%. Okay? All right, that's all we have for the 5E Part 3 assignment. If you have any further questions on this or anything else on the assignment, please feel free to ask. Thanks.